is Vs. And this would keep going. Okay, so again here we are also in quadrant 1. See, like the average voltage is always positive, right? But here the current becomes negative, so we are going to be in the second quadrant. Voltage is positive, but current is negative. So you see that if switch 1 or diode 2 or diode 2 are conducting, means that we are in the first quadrant. If switch 2 or diode 1 are conducting, we are in the second quadrant. Okay. In this case, we are like the current is ramping up. We are in the motoring mode. So here, like we are in the forward motoring part. And here this is in the forward regenerative braking. So if you look closely to class C and if you compare this circuit with class A and class B, you find out that class C is basically class A and class B put in parallel. Right? If you look at them, if you look at each circuit and the elements in each circuit, and if you make them parallel, you end up with class C. So class C can operate both in forward motoring and forward regenerative braking. Okay, so it means that you can ramp up the motor in the forward direction. You can also brake the motor. So in these cases, when you're in the first quadrant, energy goes from source to the load. In this case, when you're in the second quadrant, the energy goes from load to the source. Okay? When current is negative but the voltage is positive, energy goes from load to the source. In the first quadrant, energy goes from source to the load. So that's basically the whole point about class C. Just keep in mind that, like, about the polarities that we chose for voltage and current, and you see that like when diode 2 or sorry when switch 2 or diode 1 are conducting, the direction of the current would be in the opposite direction of the positive current direction that we chose, right? And if switch 2 is conducting, it would be like this. If diode 1 is conducting, it would be like this, right? If switch 1 is conducting, it's gonna be like this. If diode 2 is conducting, it's gonna be like this, right? So you see that for the red ones, which is S1 and D2, the direction of the current is positive, but for the blue ones, the direction of the current is negative, right? So that's what class C is. Okay, so then the next class is class D, which is also a 2-quadrant chopper, but this time this would operate in the first and fourth quarter. Okay, so let's look at the circuit first. So this is what we have. This is a voltage source that we have. We have a switch here. We have, let's call this one D2 and this one D1 and this one S2. Okay, and again, this is representing the machine that we have. Okay, and the polarities we choose for voltage, it's gonna be like this, and for the current like this. Now let's see how the circuit works. So if we have both S1 and S2 on, this is D1. Okay, if we have both of them on, then we end up with this circuit. Let me do it here. S1 and S2 both on. Then we end up with this circuit. Right? This point is going to be Vs. So this is going to be reverse bias. The same thing is going to happen here. So this is going to be reverse biased. So we have this was where S1 is and this is where S2 is, right? So in this case, when S1 and S2 are both on, then let me just like do it like this. This is gate signals. This is S1 and S2 both on. And this is when both of them are off. In this case, the direction of the current, it's going to be this way. The inductor is going to charge, right? So let me just draw the output, the current of the inductor, which is the same as output current. So the inductor current, it's going to increase, and output voltage, it's going to be equal to what? It's the same as this is output voltage, right? It's the same as Vs. So output voltage, it's going to be the same as our source voltage, right? If we turn both of them off, this is on. If we turn both of them off, then we end up with this circuit, actually. So this is positive, negative Vs, and this is the direction we chose for output voltages. Right? Why do we end up with this? Because we stored some energies in the inductor, right? So this inductor is going to act like a current source with a variable value. So it's going to decrease. It's still positive, but it's going to decrease, right? And what is the output voltage? It becomes negative Vs. Okay, and this will continue from this point on, just like continue like that. Okay, so when S1 and S2 are conducting, so here S1 and S2 are conducting, and here D1 and D2 are conducting. Okay, so when that's the case, this is basically what's going to happen to our waveforms, and you can see that